Welcome to Chapter 7, Section 4, entitled Probabilities. Alright, let's go over some vocabulary words here. So an outcome is a possible result of an experiment. So when we talk about all the different outcomes, rolling a dice has 6 sides. That is an outcome of either a 1, 2, 3, 4, 5, or 6. These are the outcome of a die. Simple event is one outcome or a collection of outcomes. Probability is the chance that some event will occur. So for this one, the probability is of a 1 rolling is one out of 6. There are 6 of them, 6 possible outcomes, and 1 is one of them. An outcome will occur randomly if each outcome is equally likely to occur. That means on a die, all of these numbers are equally likely because there is 1 out of 6. And that brings us to our definition of probability. The probability of an event is P of an event. Okay. So the probability of event is equal to the number of favorable outcomes divided by the number of possible outcomes. Okay. And favorable, another word for favorable could be desired. Okay. It's what you want to happen. Right? So take a look here. There are 6 equally likely outcomes on the spinner. All right, remember that equally likely means it's a random. All right, so find the probability of landing on 1. So you look at all of the totals. The definition is the number of desired or favorable outcomes divided by the number of possible outcomes. Okay, so looking at this, 1 happens once. But there are 1, 2, 3, 4, 5, 6 possible outcomes. So the probability of landing on 1 is 1/6. Okay, now find the probability of landing on 2 or 4. Please remember the number of favorable or desired outcomes over the number of possible. Well, a 2 and a 4. There are 2 of them. There are 2 desired outcomes, and there are 1, 2, 3, 4, 5, 6 possible. So 2/6, or reduces to 1/3. So the probability of landing on 2 or 4 is 1/3. Complementary events are 2 events in which either one or the other must happen, but they cannot happen at the same time. The sum of the probability of an event and its complementary is 1 or 100%. All right, a coin flip is a complementary event. All right, because when you flip a coin, heads is 1 out of 2 possible. Tails is 1 out of 2 possible. Altogether, that equals 1, 100%. All right, so use a spinner from example 1 to find the probability of not landing on a 6. All right, so here's example 1. Here's the spinner from example 1. Okay. The probability of not landing on a 6. Well, the probability of not landing on the 6 and the probability of landing on the 6 are complementary. So the sum of those probabilities is 1. Now you could look at all of these and you could say, you could know, you could just do probability the normal way. But you could also think to yourself that we know that the probability of landing on a 6 is 1 out of 6. Adding that to the probability of not landing on a 6 should equal 1. So 1/6 plus 5/6 gives us 1. So the probability of not landing on a 6 is 5/6. If you look at this, if you use the desirable over the possible, well, there are 6 possible choices, and since we want not 6, that means 1, 2, 3, 4, 5. There are 5 desired outcomes. So either way gives you a good choice. All right, let's find the probability on a number cube is rolled. Find the probability of rolling a 4. A number cube has 6 sides. It's basically a die. Okay? So, desirable over possible. Well, the desired number is a 4, and there should be 1 of the 4s. Over possible is 6, so your probability is 1/6. A number greater than 3. All right, let's think about this. 6 sides, numbers 1, 2, 3, 4, 5, 6. We need a number greater than 3. So that means we can use 4, 5, or 6. So the desired outcome over the possible shows that there are 6 possible outcomes, but 3 of them are what we're looking for. So that means 1/2 is our probability. Find the probability of not rolling an even number. Well, numbers are 1, 2, 3, 4, 5, and 6. We're looking for not an even number. So not an even number is an odd number. So we can do this one of 2 ways. Let's find what the probability of an even number is. Well, let's do how we would set this up first. Not even means odd. So that means 1, 3, and 5. So the desired over the possible is 3/6 or 1/2. Also now, in example 4, a sportscaster predicts that the Tigers had a 75% chance of winning tonight. Describe the complement of this event and find its probability. So the complement of winning is not winning, and the sum of the probabilities is 1. So the probability of win plus the probability of not win is 1. The probability of winning is 75%. Plus the probability of not winning should add up to 100%. So what is the difference there? What percentage do we need to make it 100. So that means the probability that the Tigers will not win tonight is 25%. So Celia guesses the probability that her parents will allow her to sleep over at her best friend's house tonight is 55%. What is the probability that Celia will not be allowed to sleep over? All right, well, this is complementary. We're dealing with not. So complementary adds up to 100%. And the probability of yes plus the probability of no should be 100. Well, you know from the story problem that 55% is the yes. And when you subtract 55 from both sides, that means that the probability of no is 45%. So there's a 45% chance that Celia will not be able to sleep over at her friend's house. All right, so that's it for the notes, but please make sure you do the CYUs on page 384, and you need to do numbers 1 to 7. Good luck. Oh, I'm sorry. And here's the classwork. This is what we will work on in class.